Okay, Stephen, welcome.
Thank you.
How are you?
Good, very good.
Okay, thanks for joining us. We know the impact you have in the computer science world. Can we say you're in the computer science?
Yes.
Yeah, all right.
The data world is what I would say, but
okay.
Computer science is the underlying discipline anyway. Yeah.
Sure. But can you, we know you, but can you please talk about yourself a little for the ones that may not know?
Well, from a computer science point of view, pretty much my whole career has been about data. Originally, I started out in scientific computing, working with very large data sets, doing hydrodynamic simulations and weather prediction and those kind of things. And then when I went back east to MIT to do my PhD work, the science laboratories on the East Coast, and I'm very biased in this, aren't as good as the science labs on the West Coast.
Sure.
So I started looking for other things to do because I'm a very hands-on person. So I ended up on Wall Street building trading systems, using data to predict the markets and those kinds of things. I went from, scientific data to very sort of commercial financial data. And then from there, I ended up working with a very large company that collects point of sales data from retailers and analyzes that. AC Nielsen is the name of that company. And so I started branching out into all kinds of data, but pretty much, I'm a data geek.
Oh, okay.
And that's, what my whole career has been about.
Data geek, right? It actually covers a lot of things, right? All right. Which years are we talking about here? Like
the 1980s, basically.
80s, when no one was talking about data.
Yeah, it was long before data was hot item. I
Right.
got lucky that the data hype kind of caught up with my interests.
Yeah,
so,
right.
Yeah.
You saw the future in a way. Yeah,
I
you
think
read
there's
it.
a little bit of luck in there, but
Okay, all right. So let's just talk about my side a little bit, and then let me ask you a couple of questions about this data world, which is like catching up globally. As an education institution and initiative, let's say, at Bilim, I'm trying to establish a foundation behind the standard curriculum, which can sometimes be, most of the times, be boring, by storifying the equations, right? How did we get to the E equals mc squared, kind of. But now with Komtaş here, we are trying to do the same with data, right? But this time we're just laying the bricks for the future. We're just building something new, I guess. A new universe. We call this digital Big Bang with Komtaş, by the way. It's like the new subatomic particles, which is called like zeros and ones. My first question would be like, can we call this a new universe? Like born out of a new
well, I mean,
Big
there's this concept of metaverse, which I'm sure most people are familiar with at this point. I don't think it's really a new concept. I mean, this idea of creating worlds and creating characters in those worlds and so on has been around for a long time. Going back to role-playing games, back in the 1970s, they had Dungeons and Dragons. It's kind of the similar kind of thing. The graphics are much better now. Back then it was with paper and pencil, and now it's with computers, but the concept is very similar. But this is not the real world. Right? Now, what you can do, however, which I think is more interesting, is create this concept of digital twins where you can model real world things and based on the data that you collect from real world things, and then you feed them into these digital twins, and then you can use simulation techniques to understand what's likely to happen in the future, and then you can make interesting decisions about, when to do maintenance on a car engine, or what actions to take from a social perspective, and so on. So this concept of digital twins, I think, is very interesting, but it's modeling real world. It's not a completely fantasy world. So I think a lot of the metaverse and augmented reality and virtual reality is a fantasy world and not really connected to what's happening in the day-to-day life of people. So I'm more in favor of this concept of digital twins, which is a representation of something real. It might be a physical thing like a machine, or it might be an organizational structure, it might be a social structure. So digital twins is a very broad concept. It's been around for a long time, but it's fed by data based on real world.
True. Maybe we should just take a step back here and define data. Like how would you define data for the layman?
Well, data, I would say, is the raw material when you observe something. Data is a representation of some kind of observation. And it might be a human recording something. Like I can take the temperature of the water and I can record it as data. And on the other hand, I can automate that recording. I could have sensors that are collecting that data through an automated means. It's still data. Data by itself actually isn't that useful until you add additional information about the data. Like this temperature that I collected, is that Celsius or Fahrenheit? So that helps the data evolve into what I would call information, which is more consumable. So data is the raw measurement and the raw observation. And of course, data can also be simulated. So I can measure temperature in actual observation, or I can simulate what would happen if I take the following actions and use scientific principles and formulations and mathematics to predict the temperatures. And I would say that's also data. It's derived data as opposed to observed data. I think it's important to differentiate between those two things.
Yeah, derived data. True. Okay, so you just talked about a little bit of like from data to information. Like we need to just maybe transform it. And we have this pyramid. Can we call it pyramid? DIKW, data, information, knowledge, and wisdom. So from this perspective, what is your take on this? Like,
I mean, that's been around for a long time. I don't find it particularly useful, or particularly, knowledge is basically, knowing what to do with the information, right? So having a certain skill set of putting something into action. And I would argue wisdom is based on experience. I tend to like the idea of, information to insight. So information is just the raw, the raw data augmented with this additional, description of what the data really means. But insight is, what are you going to do with the data? And the idea of insight means that you should be taking action, right? And I would argue you should take no action unless you're going to measure the outcome. That measurement is data. And then we want to analyze that data to understand how that action could have been better or will be better next time.
Sure. All right, thank you. So from this, our goal with Komtaş here and in general is to improve data literacy. This is the new world of data, and we are just copying the real world and transferring it to the digital world. It can be biological, it can be anything. There is no limit to the possibilities. So we need more literacy. So what is data literacy? How can we define it?
It's a fairly broad term, but I would say it's a level of comfort in understanding data and working with data. And as you mature in data literacy, then you start using data to make decisions. Rather than making decisions from the gut of your stomach, you start using data to drive the decisions that you make. You look at, for example, when you buy a product, do you look at the ratings on the product? If you don't, you just look at the picture and say, "Oh, that's a nice product. I'll buy that one." There's no data there. That's just the feeling of the picture, and I buy. Ratings is a very simple form of data, just a scale of 1 to 10. How good is this product? And then you can become more sophisticated and say, well, okay, it's 1 to 10, but what are the dimensions? Is it easy to use? Is it good value? Is it going to last a long time? And so there's all kinds of dimensions. All of this can also be quantified by data. And so you start becoming more comfortable in drilling down and getting more data to inform your decisions. And I always come back to decision making and using data for decision making as core to data literacy. Because if you understand the data and you do nothing with it, it's not really that useful. So data literacy is a culture of decision making with data and being comfortable working with data and using data in this way.
So when we say data literacy, it doesn't mean like everybody should be data scientists, right? It looks like that.
No, we don't need actually that many data scientists. The data scientists are the one sort of, creating new insights and creating new models and so on. And there are many more consumers of data than there are data scientists creating the models.
Sure. Okay, so the next question would be here, like how can we improve data literacy here? Like what should be our approach here, you think?
I think it's really giving people experience, and it should start at a very young age, right? It should be people getting comfortable with the idea of data for decision making and how to use data. It was interesting to me that during the COVID pandemic, we actually increased people's data literacy significantly without them really even intending to receive this capability, because we had these tests, these PCR tests and antigen tests, and people learned about what is a false positive and what's a false negative and what's the difference between those. This is data literacy, right? You're teaching people about, it's not just math, it's actually, probabilistic use of the data, right? What is if I do this test and it says that I'm positive, what is the actual probability that I'm positive? Because it's not the same. Because there are false negatives. Sometimes the test says that you are negative, but actually you're positive, because the test is not perfect. And people start to understand this, and it's based on data. And people started tracking, how many cases are there? And well, actually, the absolute number of cases isn't the important thing. It's the per capita number of cases, the number of cases per million, and so on. And this is all data literacy, right? People are getting comfortable. Comfortable is maybe the wrong word, but they are getting exposed to data. Every night on the news, this stuff was coming, and you couldn't avoid it. And I think COVID actually increased data literacy for many people.
More than we could, if we wanted to, right? I remember those times, like our daily topic was that. Everybody was talking about charts and, reading the graphs. And so that was a good chance, like the positive side of the pandemics maybe, right? So we should maybe like divert here and talk about this, the real foundation behind data literacy and data world, or computer science here, STEM, they call it, right? Science, technology, engineering and mathematics. So how should we look at this STEM from data perspective?
I think STEM has a foundation in data. Right? There's no science without data. Science is really about experimentation, collecting the data, analyzing the data. It's data, right? Technology, as you said, that's the zeros and ones. That's how we store the data and how we manipulate the data. And engineering is all about how to use the data to make good engineering decisions and so on. And of course, mathematics is the foundation of how to use the data. And I would say mathematics and statistics. I think that sometimes we focus too much on mathematics and not enough on the statistics, because in reality, statistics is undervalued. That people coming from good education will generally have a solid foundation in mathematics. My experience is they do not typically have a solid enough foundation in statistics. And we need to have people understand that the real world has some level of, I'll say, randomness in it, and understanding how to deal with that is also, for me, part of data literacy. But one thing that I think we get wrong with this STEM phrase is it can become very mechanical if you just teach science, technology, engineering, and math. So I like to promote in education STEAM, where the A is for art. So science, technology, engineering, art, and mathematics. And art is about creative thinking. And you might say, well, what does creative thinking have to do with data? Well, when you're interpreting the data, you need to look at it from many different angles. You need to understand, what experiment can I design to collect this kind of data and so on. And that there's creativity required in that. We don't want to be a bunch of robots. And if we think only about STEM and we don't think about creativity, then we train a generation of robots that will not be able to innovate, and that's not healthy.
Sure. Very good point. Like that's the arts there is like making all the difference, I guess. And maybe the another problem with STEM is like we're looking at STEM. It's not like they're like separate from each other. Maybe we should like have a more holistic view on STEM. They're like feeding each other. They're like helping each other.
I think in a good program, the intent is that they are feeding on each other.
Yeah, true. We maybe talked about this a little bit, but who doesn't need to be data literate? Like, is this like, when I just research the, literature here, I always come up with researches based on like business side of like how can we improve our income and, be more efficient or effective in our product sales and everything. Is it like this? Like,
I don't think of it that way. For me, use data for decision making, whether it's business decision making or personal decision making. Yeah. Mm-hmm. So if you're going to buy a car, and the car person says, well, oh, don't worry, you don't need to put any money down payment and so on. You don't need to buy the car. Just you're going to pay, 3,000 lira every month and so on and so on. And it's for 24 months or it's for 24 years and so on. If you can't do the math and understand the data and how that translates to the bottom line impact, you get into trouble very quickly. So data literacy is important for personal decision making, just like it's important for business decision making. If you're making a decision about, investing in a house or a car or, which university are you going to send your kid to? What is the cost of that? And can you do a budget? Basic budgeting is data literacy, right? It's data, right? So.
Yeah, we should look at that like that. So maybe just like final questions here. The fuss about like AI, like artificial intelligence, IoT. Like when I see videos or articles about this, it's all about magic, right? And people are talking about AI as magic. Is it magic?
It's not magic. It's just math. Yeah. Right? It's math fueled by data. So if you look at what is underlying these quote unquote AI algorithms, it's really math and statistics, interpreting the data and learning from the patterns in the data. So data is the fuel, and math is the engine. And out of that engine comes, observations that we can infer from the data. There's no magic. But again, humans are the ones that are selecting the data, transforming the data, building the mathematical equations that define the objective functions of the AI. And so, there's this magic concept that you talked about, like the black box. It's very dangerous because inside the black box is still a human fingerprint. And we need to be careful that biases of the humans who create those mathematical models can come into the AI. So we need to be much more transparent about how the data is being used and to be able to explain the decisions that are being made. So there's, in academic circles, there's a big movement called FAT. Fairness, accountability, and transparency in AI, right? Because too much becomes a black box, then people's lives start being impacted in ways that they don't understand. And the World Economic Forum some years ago predicted that the number one barrier to widespread adoption of machine learning and AI technologies is not about the technology. It's about social acceptance and perception of fairness or unfairness will dictate whether this actually gets accepted or not. And IDC had predicted that there's going to be a backlash, a 10%, backlash of people that say, no, get AI out of my life. It's not fair. I don't understand it. Get it away from me. And 10% doesn't seem like a very big number, but it actually is a fairly big number. If a 10% very loud part of the population is unhappy, they can create a movement. If we remember this Occupy Wall Street, this was 1 or 2%, and that made a lot of noise. Now imagine that, times 5, could be significant.
Sure. And maybe like in the future, if AI can just destroy the world, it's gonna be us again, right? Our fingerprints in the AI algorithms, maybe.
No, AI is not a thing. AI is just software that we build, right? True. It's us, right?
Yeah, that's a good point. All right, then let's just wrap it up here. And what would our audience here is more like youth here, like the future of our world, the next generation, new generation, we call it. The Generation Z, they call it, I don't know. What would your single advice to them would be like here?
Well, I guess I observed that in the past, you get advice from your parents. You should be a doctor or a lawyer or something like that. And my advice is, actually, you want to be a data scientist. Data scientists are the ones that are going to take that data and they're going to create new ways of thinking about problems, new ways of solving problems. And these are going to be the people that have the biggest impact on quality of life, on figuring out how to reduce carbon footprint. That's going to be with machine learning. How to improve healthcare. It's going to be machine learning. I would argue that this is the most interesting occupation for me in the future. Of course, I'm very biased in that. Harvard Business Review agrees. They wrote an article, Data Scientist, Sexiest Job of the 21st Century. I believe that. But it's not just about the math and the statistics and the data. It also has to do with communication, right? So if you build this amazing model and you can't explain it to someone without using statistical jargon, then that's no good. So, you need to have communication skills and you need to have creativity, and it's just not just about the math and statistics. There's a diverse set of skills that a good data scientist needs, including a strong sense of ethics, of how the data is going to be used, so it's not going to be biased and so on. So a good data science program in university, it really annoys me when they have a data science program and it's just a bunch of Python programming. True. This is completely missing the point, right? You should have experimental design. Sure, okay, you can have Python programming, but you should have ethics. You should have a decision theory. You should have data science is a quite multidisciplinary path. And so don't narrow yourself to just the computer science part of it, because that's doing a disservice. That's maybe where we're doing wrong. Okay, Stephen, thank you so much. Thanks a lot for all your answers here. We need it, actually. Thanks.